the building blocks of geometry. So take out a piece of paper and a pencil and let's get ready to take some notes. There's going to be a lot of vocabulary words today, but that's all right. There's no need to be intimidated. We're going to cover them slowly, and you're going to have plenty of time to cover everything that we need to cover today. The first, well, let's just get a little title up here so we can all see what we're doing today. Doing the building blocks of geometry. And on today's agenda, we are going to be covering a lot of definitions. Okay? Some of those definitions are just going to be pretty basic, and they're just going to help us, get better familiar with what we need to know for geometry. Okay? One of the first words that we're going to cover today is going to be a point. Then we're going to talk about a line. Then we're going to talk about a plane. Then we are going to talk about a line segment. We're also going to cover midpoints. We're briefly going to talk about congruency. We're also going to talk about bisecting, collinear, and coplanar. Okay, so let's just get those up. And coplanar. So those are pretty much the vocabulary words that we're going to be talking about today. And we may not necessarily go in that order, but it'll cover everything pretty much that we need to cover today. Okay? So let's talk about the first word. Let's talk about a point. Okay? A point is probably one of the most basic parts of geometry. It doesn't have any size at all. All it has is location. It's just used to describe a place that you're trying to get the reader's attention to. That's all a point is. So if we look here right now, on the right of the definition, I have 2 points of P. If you notice, it might seem like one is bigger than the other, and to the eye it is. But in geometry, in the real sense of the definition of a point doesn't really have any size. It's just trying to get you, hey, look over here. I want you to look over here, or I want you to take a look over here. It doesn't really have any size at all. It just represents a location. If you notice, the P's are also uppercase or capital letters, which is pretty big in geometry. So whenever we're talking about a point, we're denoting it with a capital letter. Next, let's talk about a line. Okay, a line seems pretty basic, but there's actually more to it than just what it seems. Let me show you a picture of a line. Okay, here we have a picture of a line. Now, a line is a two-dimensional object, and the definition of a line simply states that it is a straight, continuous arrangement of infinitely many points with infinite length, but with no thickness, and it goes forever in 2 directions. Now, let's talk about some things that you might find that are counterintuitive, things that don't make any sense. If you look at the definition here is saying that it has infinite many points. And while you're looking here, you only see 2 points. You see point A and you see point B. The thing is, though, that along the way, there's a point here, a point there, a point there, a point there, a point there. There are a lot of points. In fact, if I tried to, jot down all the points on the line, I couldn't get a pencil that was fine enough to do it. So in actuality, there's an infinite number of points on there. I couldn't count. They go on forever and ever. Something else that you might notice about the line is that it has 2 arrows. It has an arrow here and an arrow there. Those arrows are indicating that my line is going on forever and ever in those 2 directions. Okay? So it extends forever in 2 directions. The thickness, just like a point, is theoretical. It's just to get your attention to that area. One line is not ever really thicker than the other. All we know for sure, though, is that it goes on forever in 2 directions. Now, let's talk about naming a line. We might have covered this in the class before, and if we didn't, it's okay. In naming the line, we're going to use uppercase letters, okay? But there's something important that you should know about naming a line. When you're going to name a line, you have to use a special symbol above the letters. And that special symbol looks like this. It's two arrows going in two separate directions so that you know you're talking about a line. And this is going to be line A, B. Another name that we can have for this line, again, putting the arrow in two directions there, could be line B, A. So when we're talking about a line, we can name it going in any of the two directions. It can be line AB or it can be line BA. Okay? Now, let's talk about our next definition. Our next definition, our next word is a plane. Now, when you hear this word, it might be natural for you to think about an airplane, but that's not what we're talking about here. That's not what we're making a reference to. We're not talking about a regular airplane. What we're talking about is a plane. Okay? And this is a plane. This is what a plane looks like, more or less. And the definition of a plane states the following. It says, a plane has a length and a width, but no thickness. It's a flat surface that extends infinitely along its length and its width. You represent a plane with a four-sided figure. So it's kind of like a piece of paper. And the only reason that a plane stops right here along the edges is because I couldn't draw it big enough to go on forever and ever in every direction. Kind of like a line. Like you see this line right here. Well, yeah, the line goes forever in two directions. Well, why don't you draw it forever in two directions? Well, I'd run out of paper. And the same thing with a plane here. The plane theoretically goes on forever and ever, but I draw your attention to it by drawing this little square here. Now, let me show you a video of what a plane might look like. This right here is a plane. It's about as three-dimensional as I can get. And if you look on this plane, you're going to notice that there's a line on it. And this line goes forever and ever in two directions. If you look there, it goes on forever and ever in two directions. And my plane, I'm just representing it here by this little square right here, but in actuality, it actually also goes in every direction forever. Now, planes and lines also have something in common. A plane also has an infinite number of points. What does that mean? That means that if I wanted to jot down all the points that are on a plane, I couldn't do it. There's too many. It goes on forever and ever. There'd be a new dot everywhere, regardless of what this edge might show you here. The dots go on forever and ever. So a plane, like a line, goes on forever and ever in terms of how many dots it can take. So a line has an infinite number of points on it, and so does a plane. So does a plane. Now, let's take a look here at something interesting in regards to a plane. Okay, here I have two planes that are intersecting. I have this yellow plane here, which is being crossed with this gray plane right here. Okay, and you see that they kind of have a line in common here where they both touch. Now, just like, unfortunately, when we go to name a line, we use two little arrows there, a double-sided arrow above it. A plane doesn't have a special symbol in order for you to name it. However, when you name it, the name you give it depends on a couple of things. This plane right here has a point P on it. So the name of this plane is plane P. If you look here, this yellow plane is represented by this letter B. So this yellow plane here would be plane B. This gray plane here, denoted by this letter A here, is letter A. So you know that yellow is plane B and gray is plane A. And that's how we name planes. Now you notice they have a line in common here. And they touch, you can say that these two planes intersect at line KI. I think that's an I. So planes A and B intersect at line KI. Now, this also brings up another interesting point about planes, or it brings up another word that we need to talk about in regards to planes. And that word is this right here, coplanar. Coplanar is almost like a co-employee, someone you work with. Here is my plane. And if you notice, I have all these dots on my plane. I have dot D, dot E, and dot F. All these dots are on my plane. And since they're all on my plane, these dots are coplanar. Now, remember before, we said that the way we name a plane is by the letter that's on the plane or the letter that denotes it. Another way that we can name a plane is also by the letters that are on it. So this would be called plane D, E, F, because these are the points that are on the plane. Again, there's no special symbol for a plane. Let's pretend for a second that on this plane here you had the points D, E, and F. Okay? Well then, this plane, you could name it two different ways. You could name it plane P, or you could name it plane D, E, F. This little P right here is not actually on the plane. It's just to let you know what the name of the plane is. And if you notice, it's a cursive P. So those are two ways that we can name planes. Now, talking about coplanar, things that are on the same plane, let's take a look at that video again. Let's take a look of this line here. I think we can all agree that this line is coplanar because it is on the plane. So it is coplanar. If we look here, now we have two parallel lines that are also on the plane. So they are both coplanar. And if you notice, the lines go on forever and ever in that direction. They go on into infinity, as they should. Now, if we look here, I have two lines that are intersecting, but yet they're still on the plane. And since they are on the plane, the two lines are coplanar. They are still coplanar. Now the lines are collinear. They look like they're collinear. I don't know. No, they're a little bit off there. They're not collinear. But here I have two lines again that are coplanar. They are intersecting and they're on the plane. But now, let's take a look at something interesting. Are the lines coplanar here? The answer is no. They are not coplanar here. If you notice, this line is on the plane, while this line is going through the plane. So they are not coplanar. These lines are not coplanar. This line right here is on the plane. This line right here is going through the plane. So they are not coplanar. These are not coplanar lines. Talking about coplanar brings us to our next word, which is going to be collinear. Collinear. And collinear just means on the same line. So here we have 3 points, A, B, and C, all of which are collinear because they are on the same line. They're on the same line. Now, let's say, for example, that they ask us to name this line. Well, I can name this line a lot of different ways. I can name this, notice how I'm going to use my symbol here. I can name this line AC. I can name it line CA. I can name it line AB because AB goes on forever and ever. This arrow here and this arrow here tells me that this line is going on forever and ever. So I could be making it in reference to A and B. And remember that a line has an infinite number of points. So I have a lot of points here that I can't count. There's too many to count. So the fact that point C is there is not really a big deal to my line AB. I can also call this line BA. These are all the, I can also call it line BC. I could also call it line CB. This line right here has a lot of different names. But the most important thing here to notice is that all these points are collinear because they are on the same line. Okay. Now that we know a little bit more about lines, let's talk about our next word. And that is a line segment, ladies and gentlemen. Okay, let's talk about a line segment. What is a line segment? A line segment looks similar to a line that consists of 2 points called endpoints. And this would be a picture of a line segment. Here is my line segment, and these 2 right here are my endpoints. Now, a line segment, just like a line, has a special name for it. If you notice, my line segment doesn't have any arrows here. There are no arrows. It just stops there. So, my line segment would be called line AB with a little, excuse me, not line, I'm sorry, would be called segment AB. And just the same way that I can name a line 2 ways, I can name a segment 2 ways. This can also be called segment BA. Can also be called segment BA. With my endpoints of A and my endpoint of B. Let's take a look at another line segment. Here's line segment AB. Now, you should notice something very interesting here at the bottom. Here it says AB is equal to 2 inches. And then here, you have a little m, segment AB is equal to 2 inches. What does that mean exactly? What is it that we're trying to say here with that? What's the difference between the two? Well, let me tell you. Let's say that you just wanted just to measure with a ruler from A to B. And you measured it to be 2 inches. You actually take a ruler in your hand and you measure it from A to B, and it comes out to be 2 inches. Well, then you would just say that AB is equal to 2 inches. But if we are specifically referring to this as a segment, if we're referring to it as a segment, then the measure that little m right there, that little m stands for measure. Then what I'm saying is that the measure of segment AB is equal to 2 inches. So here I'm specifically referring to this as a segment. And that's why I have the little m there. The measure of my segment is 2 inches. Whereas here, this could be, little Johnny here trying to get to, his girlfriend's house, who happens to live, 2 miles away. Okay? That's just a distance from A to B. We can measure that with a tachometer. We can measure it with a ruler. You can measure it anyway. It's just we're talking, from A to B, from this point to that point. How far is it? Oh, it's 2 inches. Great. But if we're referring to this as a segment, well, then the measure of my segment is 2 inches, 2 units, 2 miles, whatever it was that we agreed on. Okay. Now, there is another image that I forgot to copy down, so I'm going to do my best to draw it in now. And it's going to look something like this. Or not. No, that's not what I want it to look like. I guess I'm just going to have to draw it. Well, let me tell you what it is first. The next special line that we're talking about is called a ray. An array is similar to a line and similar to a segment. Well, how is a ray similar to a line? A ray is similar to a line, and then it has one arrow, meaning that it goes forever in this direction. But it's similar to a segment because here I have an endpoint. So let's call this A and let's call this B. This would be called ray AB. Now, something interesting happens. By the way, here's a symbol for array. Here's how we would name it. I would have an arrow going this way, and I would have A, and I would have B. And this means ray AB. Now, something very interesting happens here. Most of my students think that since this arrow is pointing this way, well then, that's why this arrow is pointing this way. Well, let's just say for sake of argument that I had drawn it, that I had drawn my ray AB, say that I had drawn it this way. And here's A, and here's B. Well, when I go to do my notation for it, my arrow still goes this way, and it's A, and it's B. This arrow has nothing to do with which way your ray is pointing. They always point to the right. It's just a special notation to let you know that you're talking about a ray. Now, something that we should note here is that the endpoint is always the first letter in the name of a ray, meaning that we can't call this ray BA. We can't do that. That's no good. When you say ray AB, you're automatically insinuating that the A is the endpoint, no matter which way it's pointing. So the endpoint determines the first letter in the name. Now a ray, just like a line and like a segment, also has an infinite number of points on it that go on forever and ever and ever and ever. And I couldn't count all the points that I can put on here. I couldn't count them all. Okay? But let's look at some special cases where we name the rays. Let's name a multi-point ray. Okay. Let me have my endpoint here. Here's my ray. I'm going to have a point here and a point there. Here's A, here's B, here's C. And by the way, I hope we all know by now that points A, B, and C are all collinear. They are all collinear. Well, how would I name this ray? Well, what's the endpoint of my ray? Well, the endpoint of this ray is going to be A. So I could be referring to ray AB from here to the B and then going on forever, and C just happens to be one of those infinite points. Or I could be referring to ray AC, where it's going from A through C forever, and B is one of those points. Could I name this ray BA? The answer is no, because the endpoint is always the first letter in the name of my ray. Could I name this ray CA? Again, the answer is no, because the endpoint is always the first. Now, something interesting that you should know is that I can also call this ray BC, because B would be my endpoint going from here on forever. So that's one way, another way we can name this ray. So I can name it ray AB, AC, or I can name it ray BC. There's no other way to name this ray. And notice how I have the arrow here going this way, going this way. Well, let's try something different now. Let's say that I have my ray going this way. And here's my endpoint. Here's a middle point here. There's a middle point there. Let's call this C, B, and A. Well, what would be the name of this ray? Well, remember that the endpoint is the first letter in the name. So I can call it ray CA, or I can call it ray CB, that's my endpoint, or I can call it ray BA. Now that we've talked about rays, let's talk about the next word, which some of you may be familiar with. And that word, ladies and gentlemen, is congruent. Congruent means equal. In geometry, it means they have equal measure or equal lengths. Well, we've seen something like this before. Well, no, not yet. We haven't. But let's take a look at some examples of things that have equal measures or equal lengths. Here's a triangle. My triangle, by the way, is made up of 3 segments. Segment AC, segment CD, and segment DA. Segment AC and segment CD have the same measure or the same length. So they are said to be congruent. Now, there's something we're going to learn today that maybe you may not know, and it's called a congruency mark. And I'm going to show you what that is in a second. In geometry, when we have numbers that are equal, we use an equal sign. Again, I'm not referring to these as segments, because if I was, there would be a little M here and a little bar right there. Okay? So if I was referring to these as segments, there would be a little bar up here, segment AC, segment DC, and they would have little M's in front of them. That's not what I'm doing. I'm just talking about that, hey, the distance from here to here and from here to here is 3.2. So yeah, that they're equal. They have equal distances. But now, let's look at a congruency mark. When I'm referring to 2 segments, or which are really figures, not numbers, they're really geometric figures, well, this is a congruency mark. And I can make it a little bit bigger, but I am going to just draw it a little bit bigger here. It looks like an equal sign with a squiggly line on top. That means that they are congruent. So segment AC is congruent to segment DC. It has equal measure. And now notice that I'm referring to them as what? As segments. And I don't really have to put the M here because the congruency sign is letting me know that I have measured. And that's not a really big deal. Don't get bent out of shape if you can't remember that. It's okay. But just remember that when I'm talking about numbers, I'm just going to use an equal sign. And when I'm talking about actual figures, we're going to use this congruency sign. Now, another way that we can indicate congruency is by putting two red hash marks. These little red hash marks are saying to me that segment AB from A to B, that this segment from A to B, from here to here, is the same length as a segment from B to C. So actually, looking at this little triangle right here, if they wanted to say that, hey, listen, they want to let you know that these two are congruent. Let's say they wanted just to, they wanted to take out these numbers here. They didn't want to tell you what the numbers were, but they wanted to indicate to you that they were congruent. They would just put a little dash here and a little dash there, meaning that, hey, these two are congruent. So here we have these two little dashes indicating that they are congruent. Well, what happens when you have to compare more than one thing? Well, let's take a look. Here we have two pairs of sides to compare. If you notice, SR in a rectangle is the same length usually as PQ. Well, how do I say that these two are the same? Well, I do that. How do I say they're congruent? Notice how I have three little dashes here, and I have three little dashes. That means that these two sides match, that these two sides are congruent. These little double lines here, and this little double line here, means that these two are congruent. 2 matches 2, 3 matches 3. And if we look here to the right, we say that SP is congruent to RQ. We're saying that SP here, segment SP is congruent to segment RQ. And then we're also saying that segment PQ is congruent to segment SR. And the way that I know that is that this little 3 dashes matches this 3, and those 2 match those 2. Next, we're going to talk a word which is pretty self-explanatory. And that word is the midpoint. What is the midpoint? If you guess that it's the point in the middle, you're wrong. Yeah, it's the point in the middle, but it does more than just that. The definition of the midpoint, more specifically, is the point on the segment that is the same distance from both ends. So instead of just being in the middle, it's really the same distance from two ends. And the midpoint does something that has a name. And that something is called bisecting, or it bisects. If you guys take anatomy and physiology, you're going to do a dissection, meaning you might have to dissect a frog or some other type of amphibian where you take a tool and you cut it down the center, down the middle. Well, midpoint, bisect. When you bisect something, basically what you're doing is you are dividing the segment, and it's not just reserved for segments. You're dividing something into two congruent segments, into two equal segments. Let's take a look at an example of bisecting. Right here I have a triangle. And what do I know about this triangle? Well, right off the bat, I hope you realize that HJ is congruent to HL. You should see that right away. HJ is congruent to HL. Now, you see these two little dashes here. Well, and that's known by these two dashes right here. But then we take a look, and then I see these two dashes right here and here, which is telling me that segment JK is congruent to segment LK by these two notes here. And if you guess that K is the midpoint, you're absolutely correct. Because K is the same distance from J as it is from L. As it is from L. K is the midpoint. Now, you might be asking yourself, well, what about H? Is H a midpoint? Take a second to think about that. Is H a midpoint? The answer is no. H is not the midpoint. Because if you went from J to L, it's not a straight line. And the midpoint is something that is the same distance from both ends. Now, is this the same distance from both ends? The answer is yes. So technically, you could say it is a midpoint. But the one that's more obvious is K. And we'll clear some more examples up of that in class today. Okay? So now, we're going to do a couple of examples. So we're going to open up our textbooks. And on our textbooks, we are going to do let me change the color here. Page 33, numbers 2 to 6, number 8, 13 through 14, 18, 20, 21, 22, and 27. Not a lot of problems. Let's get to work, guys.